always forget to do this part. Just so we're all on the same page, our class, since it's on Wednesday, is not impacted by the Easter holiday. So obviously we have class right now and we will have class next week, Wednesday. I've had a couple students ask me questions about that, and we are not impacted because we're not close to the holiday, the weekend. So let's talk briefly about the schedule. Let me share my screen here so we are all looking at the same thing. You will note here on our Course Connect page that next week, Wednesday, we will be having group meetings. The goal of this is that we need to make sure we're all staying on the same page. Last week, we had an opportunity to meet and talk about each of your surveys. My hope is that all of you submitted your surveys to me and I said, yes, you're good to go. And that you have deployed it and you are currently recruiting participants to complete your survey. The goal is to have that be done by next week when we have our group meetings so that we can discuss what kind of data you were able to obtain. So let me actually need to turn this on because I want to make sure that we can get groups signed up for next week. All right, so which group would like to go at 1 o'clock next week to discuss their results with me?
Group 1.
All
I
right.
don't know if we're actually group 1, but eating habits.
Okay, so it was Kyle, Ashley, right?
McKenna and Norel, yes.
McKenna and
Norel?
Norel.
I always hope I say that right.
You do. You're good.
Okay, good.
Yeah, thank you for the confirmation. That makes me feel better.
All right, who would like to go at 1:30? Which group?
I can.
All right, so Grace, who's in your group? It's you and
Katie, Noella, and Chris.
perfect. All right. 2 o'clock. Let's see. Lauren, can your group go?
Yeah, I don't think that'll be a problem.
All right, so Lauren, who is in your group again?
Savannah and hold on, let me think. I don't know if she's here today.
Yeah,
I
I
was
don't
gonna
think
look in
she is.
We have 2 more though, because I know we have a group of 4.
Savannah, do you remember who's all in your group?
Elizabeth, I think.
Oh, yes, I think she is.
Yep.
And Mary Pat.
Yeah.
Yeah, they're both gone today. That's why I couldn't remember.
Yeah. Elizabeth, I think, is going to be here a little late. I don't think Mary Pat will be here. Okay, and then that should be that should be everyone. Okay. So we will have our meetings at that time, and then note on here it says 3 p.m. is our lecture. So this way that'll give me a little buffer time if it runs long with any group. So by next week, you should come prepared for these group meetings to have your data in a format that we can start doing some analysis on. So that means have it be, if you use a Google form, make sure that it's in the Excel format or Google Sheets so we can start analyzing the data. If you have an opportunity to look at the data ahead of time, that would be amazing. What you guys are able to do on your own would be coming up with a frequency table for like gender, coming up with mean and standard deviation for age, any other demographic variable. You can certainly start the analysis. If you don't have an opportunity to, it's not the end of the world. I can help out with that as well. But I want us to make the most use out of our 30 minutes. So having the data in a format that is already saved, and if you've emailed it to me ahead of time even, that would be amazing. This way I can get started and our 30 minutes can be completely focused on analysis and the results, okay? Again, my goal is to be helpful, and it is hard for me to be helpful if you guys are like, oh, well, we don't have our data, we don't know how to get it, right? Like, so some of that, work it out ahead of time will be very, very helpful. The goal is also for data collection to end by Tuesday, right? So that hopefully by Tuesday of next week, you have enough data that we can analyze it and make meaningful comments on it during our group meetings. The reason why I don't want it to go any longer is because we really need to buckle down. There's only a few weeks left of school. I want to make sure that we have enough time to wrap up this project so that you have your entire research project completed and done, because the discussion section is going to take a little while to write up. The results will be quick, but the discussion will be a little longer. So I want you guys to have ample time for that. And then we still have several lectures to go through, and we have our final exam. So all to say, there's a lot to get accomplished in the last few weeks of school. Okay, so this is saved. Now you guys can take a peek at that. It's under group meetings. Any questions about the group meetings and what's the expectation?
No, I just taking a little side note.
Yep.
How are you feeling though?
Oh, that's
Sorry.
really sweet, Kyle. I'm feeling better. Yes. Feeling a lot better, not coughing up a storm. That's what I was saying at the start of class. I've definitely turned the corner. I'm out of quarantine. So our youngest, our 3-year-old, I think I shared with you guys, she also tested positive, but never had a single symptom. No one else in the family tested positive. So we're
All right.
good. And I'm getting
Awesome.
my shot on Friday. So
Ooh, fun.
just,
All right.
yeah.
I just need, I want to double check that you're feeling good. Okay.
Feeling
Other than
good,
that,
yeah.
I'm all good with group meetings and stuff.
Okay. Anybody else have any questions about group meetings? Okay. Is someone speaking or?
No, sorry.
No, you just
I have a
want me-
song stuck in my head, so I kind of hummed it.
It's okay. No problem. All right. So let's transition to your methods how to. Your method section is due by the end of today. If you need an extension for any reason, please do let me know, but this should take you no longer than 20 minutes to complete. It is going to be short and sweet. There is a link right here that you can open that walks you through what it is I'm looking for. There's 3 main subheadings that you need to include. The first is going to be participants. You need to let me know who is it that you recruited for your study. So what are some inclusion or exclusion criteria that you utilized? And what recruitment technique did you utilize, right? So for instance, you could say, we surveyed traditional college age students age 18 to 25, and we recruited them by sending out emails to classes that had active students at Aquinas. And we spread the survey via social media alongside with a consent form that detailed who could and could not participate in our study. Okay. So that's the first section. You may write in there what your goal, your recruitment goal was. Again, we were aiming for about 20 participants per group member. So for most of you, it's going to be about 80 participants. This is, this I think here says write it in the past tense. I think I remember seeing that. This is an example. Yeah, so here it says including who they were, right? It implies describing who has already participated in. I don't want you guys to do that. I want you guys to future cast, because you don't know, you're not done recruiting. So say who you wanted and how many ideally you wanted. So that's the first section. That's the participant section. So anything that's about who you wanted to join your study, you would want to include in here. The next section is materials. So again, I want to be clear that this section you're submitting will have these subheadings. Participants, next is material. You will describe which survey you elected to give out to your participants. So if you pick the Beck Depression Inventory, for instance, you would say participants were given the Beck Depression Inventory as developed by Beck circa 1980 something, right? So you'd write the year where you got the information from. Now, if you did not take an entire survey, but you adapted a survey or pulled questions from a survey, that's how you would write it. Questions were pulled from survey by Sue and Lee, 2009 in their survey about stress in college age students, something like that. Okay, but you need to talk about the materials. So how many questions were there? And you can say, you know, participants were asked demographic questions and then they were given this specific survey. So again, this section, couple sentences, it is not long. You are just describing what it is that the participants completed. All right. For this study, you do not need a design section. So you can simply skip this here because we're not doing an experiment, but you will go into procedures. So this would be you telling them they were sent out an email with the survey in a Google Doc and they were asked to complete the survey. End of story. Okay, so again, couple sentences here. So your entire method section will have these 3 subheadings, but should not be longer than a page. And it is just you telling the reader, right? This is building on your literature review and your hypothesis. Now you're saying, this is what I'm going to do. This is who I want. This is what I'm going to give them. And this is how they're going to complete it. Okay. Questions about the method section. Should be easy peasy. Again, like 20 minutes, just literally who it is you included and what you're giving them. Okay. The beauty of these research projects is that it's hard, right? Because you start at the top of the mountain, right? The literature review takes a while to write, but then after that, it's all downhill. It's just very short. The discussion is going to be a little longer, but methods and results, it's just literally what did you do and what did you get? Like the results section is going to be probably half a page. The discussion is where you discuss the results that you got and how that circles back to your hypothesis and theories and what does it mean? Okay, so as a quick reminder, oh, somebody say something. Yes, Lauren, very good question. You asked, does everyone in our group need to submit their own? 100%. Again, this research project is only a group project in so much as data collection so that we can get more data together. The entire paper will be written solely by you. So then each section needs to be submitted individually. Great question. Okay, so if we are to go back here to our Course Connect page, turn this off. Here we are. This is your methods how-to. You can refer back to this link if you have additional questions, and you can submit it right here under the methods section. Okay.
I did have one quick question about last week's class.
Yeah.
So I was having trouble finding the link. So I just read the PowerPoint a couple times, chapter 9. Is the link just on the YouTube page?
Yes.
Okay, because I was getting a little confused, but that's because I'm bad at YouTube.
Let's see here, YouTube. Here's me. Where are my videos? Can you guys see my screen?
Yes.
Okay. Right here.
Okay, awesome. Thank you so much.
So it should have been right here, but now let me just double check that I'm not totally cuckoo. Is this the right? Multivariate correlation, chapter 9.
Yes. Yeah.
Okay.
Okay. Awesome. I just
You
wanted to check because I saw the stats videos and then I got a lot confused and on me.
Yeah, no, so this is good feedback because I do not write the chapter. I'm just writing like this one says research methods 31921. Then you see stats, research methods part 2. So I probably could do a better job of describing that. So I'm sorry about that.
No, you're all good. I just always end up watching the wrong videos, and then I did see that they were an hour long, and I was like, probably just want to double check this.
So chapter 9 is right here. It's this, that should be the start. That should be research methods 316. And then research methods 319 is part 2.
Perfect.
So, but yeah. All right. So now where do we go from here? Stop that. Let's go back over here. So did most people get an opportunity to view chapter 9? Maybe. Not so much. Okay. How far behind? We did not talk about simple experiments, right? We didn't do, did we talk
No,
about?
we
Pasta? No.
I
Okay.
don't think so.
So that is chapter 10. Let's go here. From the beginning. All right. Everybody see the slide, Introduction to Simple Experiments?
Yes.
Okay. So right off the bat, when we've talked about doing like this study, this research study that we're doing for this class, what is the difference when you guys hear study versus simple experiment? Do you guys hear a difference, or what do you think?
It sounds like a simple studies more surface level. It doesn't go as depth as a study.
Okay. So study versus simple experiment. Simple experiments more surface level is what you're
Yeah, and
Okay.
it's more of like a faster process.
okay. Anybody else? What if we just the difference between a study and an experiment?
Ooh,
Is it like with a study you're kind of observing, and then like an experiment, you're kind
So-
of like conducting something?
So Christopher, you're saying with a study you're observing, whereas with an experiment you're what?
You're kind of like conducting experiments, basically.
I love this when we define the word using the word, but yes, you're on the right track. So the idea of a study is that you're either, much like Christopher just said, you're doing an observation, or perhaps you're giving out a survey. There's a simple questionnaire. The interaction between researcher and participant is fairly limited. The idea of an experiment or conducting an experiment implies different conditions or different experimental groups. So if you think about an experiment on a new medication, that is likely an experiment because there's going to be a control group or maybe a placebo group and a treatment group. And then you are comparing the way in which each group behaves to try to identify what seems most meaningful or most predictive of whatever it is your dependent variable is you're predicting. So an experiment is kind of a more complex level study. A simple study, like we're doing, is just giving out a questionnaire, for instance. So there's limited interaction, and it is harder to show causal links between an independent and a dependent variable in studies versus experiments where you're controlling multiple groups. Okay. So that is the bulk of what we'll talk about today. We will discuss 2 specific examples of simple experiments. We'll talk about experimental variables and what those look like. And then specifically, we'll look at causal claims, and that has to do with covariance, temporal precedence, and internal validity. So we will talk a lot about that in the next couple of weeks. And then lastly, we'll look at independent group designs versus within group design, and what are some pros and cons of both of those, and how we can assess, again, causality. So that is the goal for today. Let me make sure that's on. All right, so the 2 examples are as follows. So there's, the Seeing Red experiment. And I don't know what's going on with my slides. They're a little wonky. I feel like they got shrunk here. And then there's the pasta example. So we'll start with the Seeing Red example. Researchers Elliott et al. In 2007 wanted to evaluate academic achievement and the color red. More specifically, if you guys think about getting grades back, like in elementary school or high school, what color ink did a teacher use to correct?
Red.
Red, right? Like, oh, whoa, Kyle, sounds like there was some trauma there.
So much. I was really bad at writing.
Right? Okay, so the idea of red ink represents a correction, right? Or there is an image or some sort of connection that you make between your performance and how much red ink you see. Usually those two things are linked because that's how it's graded. So the idea is based on the approach and avoidance theory is that we as humans either work towards success or pleasing results in some way versus we try to not fail, right? We avoid failure. So it's approach success and we avoid failure at the same time. So when diving in a little bit deeper, there's this link between this visual cue that we get and a certain level of anxiety or this sense of inferiority in regards to our performance or ability if there is the presence of the color red. So their thinking was, or their hypothesis was, if we expose students to the color red on the test booklet, that will lead to a worse performance for them. So that just introducing this ink color will cause a decline or a reduced performance by the participants. So that's their hypothesis. So to test this out, they had participants solve anagrams for 5 minutes. In fact, they had a couple of different ability tests, but the first one was anagrams. So for instance, if they saw the letters K, R, and ID, they had to flip those around to come up with the word drink, right? So some sort of mental verbal puzzles. The ID on their booklets were either written in red, green, or black ink, okay? So that was one set of people, one set of group. They did anagrams. There were the 3 different colors that they were exposed to. And in other conditions of this experiment, they had the participants, instead of just doing anagrams, they did a vocab analogy and another group did math problems. And with those, the cover test booklets were either red, green, or gray. Okay, so lots going on already in this, right? So they randomize their participant pool into 3 conditions for the first one, for the anagrams. What were the 3 conditions?
So they had cover of test booklets were red, green, or gray.
Yes. So the condition that they're placed into, right, the group, is the ink color. Yeah, Kitty needs a lot of love today.
Oh, he just loves it.
Now, in the second experiment, instead of doing anagrams this time, they were doing vocab tests. In the third one, they were doing math problems. And again, the conditions were the ink color. This time it was red, green, or gray instead of black. Okay, so that is the setup, okay? The hypothesis again is what? Having the color red will lead to a reduced performance by participants. And here's what they found. This was the number of correct anagrams, and here's the division of scores based on the ink color they were exposed to. What conclusion might you draw from this graph? This first one here.
So black had black was better for answering questions because of and then red was significantly lower. And I don't really know if that's significantly lower. That's 2 questions.
Well, it's a very good point, right? Like we don't have statistical significance here, right? We just have it graphed, and visually we could certainly see that there was a difference in performance. Black and green hung together more closely at a higher performance than red. Although this to me looks orange. Anybody else see this?
Yeah, it's orange. That is just orange.
Okay, I don't know what I did there with my slide, my colors. Something's wonky going on today. Okay, so let me see if I have the actual stat for you guys. I didn't write it down. Now, someone else than Kyle, for this study on vocab, what conclusion can you draw from this?
That green scored better than the other 2 colors.
Okay. Is there one that scored particularly lower, would you say?
Yeah, the red one still.
Red, right. Like this is, again, a huge depression in score here. Red is at 9.5 words correct, whereas gray is at 12.5 and green is 13.5. Again, we don't have whether that's statistically significant, but just visually, you can see that there's definitely a drop in score. Okay, what about for math?
Red is slightly less than green and gray.
Okay, again, there's a pattern where green and gray are hanging together, much like over here, you know, black and green were hanging together, and red is much lower. Okay, is there consistency across these three results?
Yes, red's
Yes.
always slightly less.
Right. So without having the statistical confirmation here, whether it's statistically significant, it does seem like it follows the pattern of the hypothesis, which is that participants' performance when exposed to red ink inside the booklet is worse if they are shown red ink than green ink or black ink, regardless of the type of task. Okay. So this is an important distinction too. In this experiment, not only did they have three conditions, right? They could have just done black and red or green and red, but they wanted to make sure that it wasn't just that one color would make you better somehow. So they added a third, which was more of a control between black and gray. Those are, I would say, non-colors anyway. And then they didn't just pick one specific task, because it's possible that students may perform poorly on anagrams, right? Because they're just hard. Or like the SAT, like analogy kind of questions, those are hard. So, but they made it a variety of it. So one was a non-verbal task. They did math. The other one was completely verbal with vocabulary. And the other one was like more verbal logic with the anagram. So this is a very strong study, right? In order for them to say that there is something of significance going on with the color red, they really evaluated multiple confounding variables that could be present. And we'll talk about that in a minute. All right, so that is the first experiment. It is the seeing red experiment. The second experiment has to do with eating pasta. So researchers, this is out in 2012, were curious as to the amount of food that people would both place inside their bowls and how much they would ingest, and whether there was a relationship between both of those items and the size of bowl that they were given. So there are two different conditions. There's a large bowl condition and a medium bowl condition, meaning this is what participants were given to choose from. It was like a buffet line. Your book has much more detail on it. You can read that through. But the gist of it is they were handed over one specific size of bowl, and then they served themselves pasta. Researchers then recorded how much was served with the use of a scale. So, you know, they finished putting the pasta on, then they weighed the bowl, and then people went and ate, and then they weighed the bowl again to see how much they consumed altogether. Okay. Part of their hypothesis was that if individuals are given a medium-sized bowl, that they would serve themselves less food and eat less food. That was part of the hypothesis. So if you think about this being, you know, part of what you would assume in terms of a diet, that's often something they say is just eat from a smaller plate. That was part of their hypothesis as well. So the question was, is there an effect as to the serving bowl size and the amount of pasta that individuals consumed? So this first graph, bless you here, shows the amount of pasta that was served, how much did they put in their bowl. So you see here the quantity varies depending if it's a medium or a large bowl. And then how many calories were actually consumed is shown here between the medium bowl and the large bowl. So what conclusion would you draw from these graphs?
That the large bowl does or is supported by you eat more calories. But can I have a question?
Yeah.
So you pick the bowl, right? Like,
No, very good question. So it was assigned. So
Okay.
here's your goal. Okay,
Okay,
but say
'cause I-
why you asked that question, because that's important.
Because if you're a runner and you're hungry, you're going to get the large bowl every time because you just need more calories.
Right. So we
Okay.
will talk about this in just a moment because there are so many factors with this, right? Like what if, so yeah, what if you're super hungry, right? It's 2 o'clock in the afternoon, you haven't eaten anything all day, and they're presenting you with the most delicious looking pasta. Maybe you pile it on, right? My question of this, and the textbook does not cover it either, is do we know if people who had a medium bowl, did they go for seconds? Right? So if you have a smaller quantity, maybe that's what you start with, but what if you just walk back? So there's no answer.
Yeah, that's really that's even better because that would be interesting because if that is, that's more than the large bowl,
Right.
like in calorie intake. Oh, that's cool.
Because if you look at this here, that's like 100. I mean, I'm eyeballing it here, maybe like, yeah, around 150, maybe 160 calorie difference. But if you do 2 of these, then obviously it's going to skyrocket above the large group. Anyway, so yeah, on average, actually, I wrote it here. It shows about 140 calories more was consumed by the large bowl participants than the medium bowl. So based on this study, they were able to conclude that the size or the serving bowl that was given actually influenced how much people ate and how much they dished out for themselves, just to begin with. Okay, so those are 2 examples. We're going to keep coming back to it in this lecture, but at least they're introduced. Here's what they're about. So let's define a few things here. What are some of these experimental variables? So an experiment is at least one variable that is manipulated and at least one variable that is measured by the researcher. That is the definition of experiment. A manipulated variable is that the researcher assigns the participant to a particular level or value of that variable. So in the seeing red, participants, the way the researchers did it is they rolled a dice. And so based on that roll, they were assigned to one of the different categories there, whether it was going to be red ink, green ink, or gray ink. And with the eating pasta experiment, they flipped a coin. Do you get medium or do you get large? That's what determined it. So those are the manipulated variable or the conditions that were assigned. The measured variable, it's the record of what has happened in terms of the behavior or the attitude based on a self-report, behavioral observation, or physiological measure. So the measured variable in the pasta example would be how much they actually consumed. What is the amount of food that they consumed? The measured variable in the seeing red is their the correct scores that they received on the anagrams versus the vocab task versus the math task. Okay, measured variable. All right, quick refresher, because we all know this here, but the difference between an independent and a dependent variable. The independent variable is the manipulated variable. And researchers have the right, the freedom, the independence to assign to each participant which condition they fall into. Those are the levels of the independent variable. So for instance, in the seeing red, the independent variable would be the color of the ink, right? There's different levels based on the colors. And then the dependent variable is what is actually measured, or it's the outcome variable. So the dependent variable for the seeing red experiment would then be how they scored, right? What was the result of their performance on those tasks? That's what they measured. Okay. Let's talk briefly about control variable. Control variable is any variable that an experimenter is holding constant, okay? The fact that the word variable is in there can be a little confusing because that implies variation, but no, you're holding it constant, you're controlling for it. So what would be the control variable in seeing red?
The green.
Okay,
Would it
think
be the game they played?
black or gray, what was that?
The game they played? Anagrams or
So that would be, let's see, could you make that a control? Yeah, I think you could because they all played the same thing, That's correct. Mhm. And then for the pasta example, the control variable could be the type of pasta they got, okay? That you held that constant. So it's not like you have the most appetizing looking pasta bolognese when you've got the large bowl participants, and then, you know, the super dry, crusty Alfredo that's dripping in grease for the medium. You can tell which one I prefer clearly.
I'm
yeah.
so hungry now.
Kyle's like, give me the large bowl. But obviously, you are trying to hold that constant, right? Because what would happen if I had two different choices of pasta? Would I actually be measuring the impact of the bowl size? Or would I really
No.
be measuring people's preference for pasta? Right? Like we can't be doing that, because that would be a confounding variable. I would be then drawing incorrect conclusions as to the relationship between these two variables that have nothing to do with the serving size of the bowl, but has far more to do with how appetizing the pasta looked, or you know, how good it tastes, you know, those things. So, okay. All right. So why can experiments support causal claim? When we've been so careful at talking about relationships and correlation and association, how are we bringing up causality just in general? And the reason is experiments establish covariance, meaning as levels of an independent variable vary, do they covary or do they vary at the same rate as my dependent variable? If so, then you can talk about causality, okay? And the way that would look like, simple example would be, I am driving my car, and every time I press on the gas, my car goes faster. If I let go of the gas, my car goes slower. That is a causal relationship. My pressing of the pedal is impacting my speed, right? As one variable varies, the pressure that I put on the gas pedal, the other variable varies accordingly, my speed, okay? So that is what is meant by covariance. So when you have in any experiment, if your independent variable is varying your dependent variable at the same rate that they move in the same direction, you have instances of covariance, okay? Experiments also establish temporal precedence. You can actually see if your independent variable comes before your dependent variable. Therefore, any change in your dependent variable is inherently then due to your independent variable. And then well-designed studies and experiments can actually establish internal validity, which shows that there are no other alternative results for what you observed in your dependent variable. So we'll dive into each of these individually here. All right. Covariance. So the independent variable answers the question compared to what? Okay. So you have a, okay, great. You can have a comparison group. So in our seeing red example, we had comparison groups. There's the red, green, and gray condition. So then you're able to compare those and how they do. Now the question for the eating pasta example is having a larger bowl, does that lead you to eat more? That is the question that's being asked there. So that is the independent variable. You have a comparison group. Covariance means that you are looking at both the condition and how it's impacted by the outcome, okay? So does having a different size bowl impact the outcome of how much pasta you eat? The answer, according to the study, says, yeah, it does. Anything else I want to say about that? Okay. And then the control group, treatment group, and comparison group are defined as those. So control group is they are not getting any treatment, okay? It is not always necessary to have a control group. There are some experiments that we'll talk about further on that it's not a necessity. You can have a pre-test, post-test, something like that, not necessarily have a control group, but those are helpful to have. The treatment group is the treatment condition. So it's the thing you're testing. It's the non-neutral level that you're trying to see if there's an impact. And then the placebo group is another form of control group. So it's when the control group is exposed to something that is not actually treatment, but it appears to be treatment. You guys have all heard about placebo groups? Okay. Yeah, the placebo effect, as discussed in your textbook, shows that there's really even levels of impact of placebo group, right? So taking a sugar pill is more helpful than like a fake treatment, but yeah, an injection of saline is even more helpful than a sugar pill, which yeah, shows how powerful the mind is, because neither of them really do anything. But all right, so that's for covariance. Temporal precedence. That's the idea that the cause variable, or the variable that is leading to a change in the dependent variable, comes before the effect variable. So in the pasta example, what we saw is that the experimenters manipulated the serving bowl size first, and then they measured the dependent variable second, looking at how much food they consumed, to make sure that the causal variable came before the effect variable in terms of time. Now, when we look at correlation, correlational studies do not allow us to determine what comes first, just that the two have a relationship with one another, okay? But when you look at an independent variable that or in an experiment where this happens definitely before that, you have that temporal precedence, and that allows you to get closer to causality, okay? Okay, so just so we're clear, an idea on a correlation that would be in line with the pasta example would be maybe going to, I think Olive Garden does this. You can order like the lunch plate versus the dinner plate. So there's always a smaller option, right? And then you could see how many people order which of those two, and then weigh their plate after they're done eating once they leave to see how much they consumed, right? That would be a correlational study. I'm looking at the relationship between the size of bowl that people order and how much they complete, like what percentage completion do they have of their dish. The weakness in that is that it introduces a bunch of other variables that we cannot control for. How hungry are they? Did they share a plate? Maybe it was economical. They ordered a really big one and just split it in half. There's just a lot of other factors. In this particular pasta experiment, the fact that we give them the bowl that they're allowed to choose and then do the measurement really allows us to say that this happened before that. And that is the link, that is the temporal precedence. Does that make sense? It's a small fine-tuned difference, but okay. All right. Lastly, well-designed experiments establish internal validity. Okay. We've talked about validity and reliability all semester long. They are very important. We need to keep that in check. The way we do that is by asking ourselves, is there any other factors that could have impacted the results that I received? In other words, is there any confounds to the design of my study, or any confounding variables that have inserted themselves as a way of a third variable explanation? Okay. So I think we've talked about this a little bit already, but really the definition of a confound is this idea that it confuses you. It's an alternative explanation that can threaten the internal validity of your study. So for instance, this is one of the examples that's discussed in your book. If the people who were given a medium bowl were also given less appetizing pasta, just didn't look very good, was nice and dry, or dripping in oil. Okay, like either way, that's no good for pasta. But that the large bowl group was given really appetizing looking pasta, the pasta quality becomes a confounding variable, meaning this likely explains our results far more than the conditions we laid out of medium versus large bowl. Does that make sense?
Yeah.
Okay. Let's see here. Anything else I want to say about that? Selection effect is another big thing we will talk about again next week as well. what might be the issue with letting a participant choose whether they get a medium bowl or a large bowl?
That's just introducing so many more variables. As you brought up earlier, it could be about like being economical. And it's like, oh, I'll grab one plate and then all three of us can split it because I loaded it up.
Right.
And there's just so many more moving pieces that you can't account for.
Right. Absolutely. So the motivation behind a participant making that choice is going to impact that, right? Like, is somebody standing in line next to their best friend and they see them grab a medium bowl? So then there's social pressure. I should only grab a medium bowl. You know, what's their economic status? This is going to be their only meal today. At which point they're like, give me the big bowl. I got to load it up, right? So if you let the participant self-select, you're no longer in control of the experiment, and it introduces other possible variables that could explain away your result that have nothing to do with what you're trying to measure.
Now, would that become like, would that be approaching the territory of a study because it's more observational?
It could, yeah, you could do a correlational study and just observe how people choose, and you could have a hypothesis about gender, for instance. Gender will pick one size, you know, bowl versus another, or if people are in groups versus by themselves. Absolutely, yeah. But if it would not be a strong experiment that would show the link between the size bowl that you are given and how much you eat. Yeah. The same problem here. This is a slightly different selection effect. But if you're eyeballing people and you're like, oh, you get a medium bowl, oh, you get a large bowl. If you're just picking it based on the type of person that you're seeing, right? You look like an athlete, large bowl. You look like you could lose some weight, medium bowl, right? Like, we're not doing that. That kind of selection effect will skew your data also. You've stacked the deck, right? Don't want to do that. So random assignment, again, this one, the way people were assigned one group to the other was just by flipping a coin, so completely random. So that's the way we can minimize threats to internal validity. Okay. Design confound just more broadly, if you have some sort of second variable that varies systematically along with the independent variable, but it provides an alternative explanation. So for ink color, let's say if anagrams were really, really difficult, that could have confounded the impact of the ink color, right? If the test itself was so hard that it just really reduced everybody's scores, that could be problematic. Again, that threatens internal validity because we are not necessarily measuring what we think we are measuring. The issue that we try to minimize as much as possible is this idea of systematic variability, okay? When it is systematic, that means there is something inherent in our design that is causing a third variable to have greater impact, okay? So if participants in the large serving bowl group had higher quality pasta than those in the medium group, that would be systematic variability. That variability is only seen in one condition, so it's skewing the results. If it is unsystematic, that means it's random or haphazard or could be affecting both groups. So it's not usually a confound as much, but it can make it difficult to, you know, really discern a difference between our levels of dependent variable. Okay. All right, selection effect. This was an interesting study that's discussed in your book as well. This is by Lovaas in 1987. So selection effect, just briefly, it's when an experiment, when participants in one level of the independent variable are systematically different than the participants in the other group. So there's an inherent difference in the participants between the two conditions that alone could explain the outcome variable, not necessarily the treatment condition, okay? So in this particular study, it was to evaluate intensive treatment for children with autism, okay? So they were invited to participate in this intensive program, and some children did receive it and others just continued their usual treatment. So this was not one that had like a control group where there's no treatment. Again, that wouldn't be unethical. So we have the treatment as usual and then the intensive treatment. But they were not randomly assigned to either one of the groups because some families live too far away to really participate in the intensive treatment. So they found that the symptoms of autism for kids in the intensive treatment group showed greater improvement than those in the treatment as usual group. The issue is, though, there was a selection effect because some families selected into the intensive treatment and others just couldn't select in because of distance and, there's an impossibility there. So it goes back to, if you selected to have treatment 5 days a week, what kind of person are you that you've selected that? Not in like, who are you? But I just mean like, there's maybe something about the motivation that you have towards getting better that is different than those who are not in a position where they can participate in that intensive treatment. Okay. So yes, it shows that there's a difference in how they improve, but that may systematically have to do more with the participants than the treatment itself. Okay. So the way we avoid selection effects is through random assignment, right? So you are randomly assigning people to each group. And by random, you as the researcher are not selecting and the participant themselves is not selecting. So there is a random assignment into different conditions. Okay. Hopefully that all makes sense, right? Any sort of selection leads to some level of bias one way or the other, either from the researcher's point of view or from the participants. So. All right. Unsystematic variability is, again, that is different than a confound. So if you are randomly assigning people, again, you're flipping a coin as to which size bowl they get, you're going to get a mixture of people on either group. If it's unsystematic, that means that you've not stacked the deck in one way or the other that could explain why you're getting certain results. So for instance, you have a split here. You can see there's some people who didn't eat breakfast, so they might want to eat a lot more, but they should be on this side as well. Or maybe on this side, you have a light eater, right, in the large bowl, but you might have a large eater in the smaller bowl. You've got variability on both sides, okay? So that allows you to really notice, I am actually just measuring the difference between the size of bowl. I didn't put all the super hungry people in the medium bowl and then the gluten intolerant folks in the large bowl study, right? I didn't stack the deck that way. So individual differences don't become a confound unless one type of people end up in one group systematically more than another group. Then it becomes a systematic variability, no longer unsystematic. All right, so another way that you can avoid selection effects is by making matched groups. So for instance, if I'm doing a task and I am trying to figure out how well people have done on this task, and I happen to have their IQ scores, one of the ways I can do that is take all the participants and line them up from the highest level of IQ to lowest level of IQ, and then I, randomize it. I match them up. So the highest IQs in this group, next highest that one, third highest in that one, and then I start over and I keep it so that my groups are mostly matched. I don't end up with randomly the crazy smart people in one group and then people who need help putting their pants on in the other group, okay? So more of a matched group idea. Is that tracking? Making sense for people?
Yeah.
I feel like I'm doing a lot of talking at people. Any questions? Are you like, this is just straightforward, simple?
Oh, I can ask a question. Okay, so when would we use the selection effect the most? Like what would be a good example? Because in my head, I'm imagining like school lines, like graduation. Like, okay, you have to go with that kid because they're alone. No one's with them.
Yeah.
And go with the semi-popular person too. So then we have the distribution of not so popular, really popular, right in the middle.
Right.
I'm just trying to think what would be a great what's an actual experiment that like you'd use that for?
Well, so the first thing that comes to mind is not so much an experiment as much as class distribution in elementary school, right? And so they try to do matched classes for that, right? Because you don't want, best world scenario, you don't want all the troublemakers in one class. You don't want all the super smart kid in the other class because then they can't learn from one another. So then you try to have as much as possible matched groups. Same with gender, right? You don't want a class with 22 girls and one boy. That's going to be a tough year for everyone, right? So that would be an example of doing a matched group. Does that make sense?
Yeah, no, yeah, it makes a lot more sense. So this is less about like experiments and studies and more about practical uses.
Well, it's both, right?
Okay.
So yeah. I mean, in experiments, you would want to try to have matched groups.
Yeah, because you don't want it lopsided.
You want to try to control for as many things as possible. So you don't want to randomly end up having, and we'll talk about this later, with like mothers bonding with children. You don't want to have one condition where they're all first-time moms and the other one where they have 3 kids. Like you want some variability so that your groups are matched. If you think about any experiment, you also usually want match in terms of ethnicity and racial breakdown, right? So that you don't end up saying like, well, there's a significant difference between these conditions, but that was a completely white homogenous group and here's a diverse group. Well, did I actually measure what I said I measured, or did that get confounded because I've got some systematic variation?
Oh, okay. I'm just so like in our ink coloring thing, if we have the control group all be colorblind, it doesn't make sense.
Exactly.
Okay, awesome.
Yep. All right. Why don't we take a quick 15-minute break? We're about at the halfway point, and then we'll come right back. So let's plan on rejoining at 2:15.
Perfect.
All right. See y'all in a minute.